Okay, let's go through a couple practice problems just to refresh your memory. So, if something falls or is dropped, we can always assume Vi is equal to 0. So that's great information to have. And it is heard hitting the well 3.41 seconds after being dropped. So that tells us the amount of time it took to reach the ground. So 3.41 seconds. Determine the depth of the well. There's one other key piece of information that we can assume is true, unless otherwise told. Acceleration is equal to negative 0.8. The reason I'm going to say it's negative 9.8 is because that's the acceleration due to gravity on Earth. And Patrick, while it may be a fictional character, it is happening on Earth. So the depth is our unknown. So that means our displacement or distance is the thing we are solving for. The only equation that has these four things is this. Delta D is equal to Vi times T plus 1/2 AT squared. One thing to note, sometimes I'll write the T with the triangle. That triangle is delta, meaning change in time. And sometimes I'll write it without. Really, this is only when I'm lazy, but they are the same variable. So then all I have to do is plug it in. So if I plug it in, delta D is equal to 0, because that's my Vi, times 3.41. Doesn't really matter, but I'll do it anyway. That cancels out. Plus 1/2 times negative 9.8 times 3.41 squared. Okay, plug it into my calculator. And it gives us an answer of about negative 57 meters. Okay, pretty simple, pretty straightforward. Let's do another one. This time we're going to solve for acceleration. The way I know this is because I did write the problem, but I'll read through it for you. The tallest point on the moon is Mons. I don't even want to try that. Say that Huygens, with a height of 18,000 meters. An astronaut drops a hammer off the edge of the cliff, and it takes about 149 seconds to hit the ground. What is the AG? That means acceleration due to gravity. I'll go ahead and write that as our unknown. On the moon. Now, with a height of 18,000 meters, that means we are solving for, or that is our displacement, 18,000. When it says drops, that means Vi is equal to 0. And it takes about 149 seconds to hit the ground. So my delta T is equal to 149 seconds. You already know the AG because I wrote it earlier. The only equation that has these four things is displacement is equal to Vi times delta T plus 1/2 times A times T squared. All right. The tricky part here is plugging in things correctly because it is a little different. So this time we already have displacement. 0 times 149 plus 1/2 times AG times 149 squared. That cancels because 0 times anything is equal to 0. Now I have 18,000 is equal to 149 squared is 22,201. 201 divided by 2 times AG divided by 2. 11,100.5 All we gotta do is divide 18,000 by that number, and we get our answer of 1.62, which we can check, and we will see that the moon's gravity is 1.62 meters per second squared. So, you're welcome. I make good problems that make sense, like I've said. Alright, this time we're going to be solving for time, because it's asking for how long was it falling for. That's like the same thing as saying how long it took you to get from point A to point B. We're usually asking for time. I know long can also mean distance. The English language is dumb, and that's just how it is. Hopefully you can recognize when it's asking for time and when it's asking for distance. The biggest takeaway here is you see this 15 meters before. You know that's distance, so it must be asking for time. Anywho, Dwight drops. That tells us VI is equal to 0. A watermelon off a building where it hits a trampoline. If it falls 15 meters, how long was it falling for? So VI is equal to 0. Delta D is equal to 15 meters. Acceleration on Earth is equal to negative 9.8 meters per second squared. Since we're falling down, that means we have a negative distance we fall. Unknown is time. Like I was saying earlier, again, the only formula that we know that has those four is this one right here. Anytime you aren't given the final velocity, but you are given an acceleration, you can pretty much assume we'll be using this formula. All right. Now, negative 15 is equal to 0 times time plus negative 9.8 over 2 times time squared. So right here, these zeros cancel out. Negative 15 is equal to negative 4.9 times t squared. Remember, when you divide negative by negative, you get a positive. Basically, all I want you to make sure you do is make sure these signs match. So if you say acceleration is positive, then make sure that you say displacement is positive. These always need to match, okay? Otherwise, they can get real wonky. So when you divide 4.9 over to both sides to get rid of anything touching this variable, you get your answer of 3.06 is equal to t squared. The way to get rid of the square is to square root. So we square root our last answer, and we get a delta t equal to 1.75 seconds. A quick little shortcut. Don't memorize this, but since most of the time we can say VI is 0 and we can cancel things out, we basically did t is equal to square root of 2d over a. Okay? Don't memorize this, though. You know what? I'm cutting this out. We're cutting that out. All right, moving on to the next problem.
You'll never catch me, Krabs. Not when I shift into maximum overdrive. Hi-ya! I knew I should have gotten the turbo.
A man went skydiving, assuming no air resistance. What was his speed after falling for 23 seconds? Ooh, this one might be a little bit different if you haven't noticed. So, he went skydiving. 23 seconds. That's our time. Since there's no air resistance, we can assume that our problem will work pretty well. A is equal to negative 9.8 meters per second squared on Earth. Delta t is equal to 23 seconds. If he said we were falling, we can assume VI is equal to 0. A lot of these problems we're going to assume VI is equal to 0 unless we tell you. The trick here is we're not asking for displacement. We're actually asking for VF. So this has got to be a different formula than what we've been using. In fact, it's one of our old formulas, our old friends. A is equal to VF minus VI over T. Then all we got to do, plug things in. Negative 9.8 is equal to VF, which is what we're solving for, minus 0, divided by 23. Then we're left with negative 9.8 is equal to VF over 23. Multiply both sides by 23. And you get your final answer, which is 225.4 meters per second. If you're confused, I'm going to show this one last time. So we had our A is equal to VF minus VI divided by time. We plugged it in. So negative 9.8 is equal to VF minus 0 divided by 23. In order to get 23 over to the other side, we got to multiply both sides by 23. And that gives us our answer of negative 225.4. It is negative because we're falling down. If you just give me the number, you will be fine though.